Let's take a look at this coding problem where we say we are given an array, and in this array every element maintains the max heap property, and we know the max heap property is the parent should always be greater than its children. But in this array there is one element at index idx which does not maintain the max heap property, and the way it violates that property is that this is smaller than at least one of its children. So if we take a look at one example array, we'll understand the problem very clearly. Please, just for understanding, array is actually representing a max heap. If you see here, 25 is greater than all its children, right? So each element except one maintains the max heap property, and one element, that one element which violates that property, is smaller than its children. So 25 is greater than all the children that 25 has. If you look at 4, 4 is not greater than its children. So 4 is an element which is violating that property. Rest all, if you look at 18 is greater than its children, 7 is greater than its child, 9 doesn't have children, so 9 maintains the property, 10 maintains the property. So if this kind of scenario is given, if this kind of array is given to us and somebody says this is almost a max heap but one element is violating that property, so the question given to us is how do we convert this array into max heap? So this is the coding problem that we need to solve. Ultimately we need to write code for this, and we say like how do we convert this array into a max heap, right, when one element violates the property. So how do we go about it? If we look at this carefully, since 4 is smaller than its children, what we can do is, let's say 4 should be moved somewhere down, and the way we move 4 down is, what we can do is we can either move 4 here or we can move 4 here. Now but if we move 4 towards this side, 7 will move up. Then the problem is 7 will again violate that max heap property. 7 will be less than 18. So what we should do is, the element which is violating that property, let's treat this as a parent element. Let's compare this parent element with its left child. Left child is 18 and right child is 7. Now comparing 4 with these two, whichever out of these three is maximum, that should ideally move up and 4 should be swapped with that, right? So that is what we need to do. So since out of these three 18 is the max, so we should do one thing. 18 should be moved over here and 4 should be removed from here, and ideally what we are doing is we are swapping 18 with 4. So this way we have made sure that this element, this position is proper. Now after we have moved 4 here, again the chances are this 4 will violate that property. Then what we need to do is this 4 also we need to move down, looking at this with its children. Now let's take a look at 4 with its left child and right child, and what we realize is the right child is actually bigger out of these three. So 8 comes here and 4 moves down further, right? So if 4 moves here, 8 comes here. Now if you see, this actually eventually becomes a max heap. In this case, the strategy that we have taken is we need to shift down that index by comparing it with left right child, and we need to keep doing till we get that element to its proper space. Now if we target, if we ask about, if we keep doing this, what is the time complexity of this solution? Now 4 we compared with this and left and right child, so comparison is, you can say, order of 1 operation, but we move 4 down in one path, either left side or right side, right? So this is like doing a binary search. You are going either in the left half of the array or on the right half of the array. So ultimately moving 4 down is bringing 4 here and then bringing 4 here. So this is the path we took. If there were total n elements in the array, the time complexity would have been log n. If you remember clearly, when we had a discussion about binary search, we talked about how this is coming out to be log n, right? So moving it down takes log n. Now next question is, what is the space complexity of this? In order to move the 4 down, we did not take any other array or any other data structure. So ultimately, space wise, we are not taking any additional space. 1 or 2 variables is fine, that is not counted towards the space complexity. So this is order of 1 space complexity, order of log n time complexity solution. So next we'll go and take a look at the coding of this step by step, and then we'll move on to the next problem.